This is the guided note video for graphing absolute value equations. Graphing absolute value equations will use the same strategies we use to graph polynomial functions, which are discussed more in Algebra 2 and Pre-Calculus. When graphing absolute value functions, we need to find our vertex and then plug a few inputs into our equation to see what our outputs will be. We can then graph these points to get our graphed absolute value equation. So let's work through an example to learn how to graph absolute value equations. I think that would be the best strategy. Okay, so we know it is an absolute value equation because of the bars. Okay, we have this x plus 1 and it's surrounded by these bars there. Okay, and again, absolute value refers to the distance away from 0 on the number line. So first, as I mentioned above, let's find the vertex. The vertex is the highest or lowest point of a function. We can find the vertex by taking the expression in the bars and setting it equal to 0. Okay? Sorry, I didn't give you enough space there. So when we solve for x, that will be the x-coordinate for our vertex. Pause the video if you need more time. So let's do exactly that. Okay, so for our equation above, we are going to take the x plus 1, because that's what's in parentheses, and we're going to set it equal to 0. Okay, so to get x by itself, I'll subtract 1 from both sides. When I do this, 1 minus 1 cancels, so we get x equals negative 1. Okay, so we know our x-coordinate for our vertex is going to be negative 1. Now we must find the y-coordinate for our vertex. We can do this by taking our x-coordinate and plugging it in for x in our original given equation. Okay, so I am going to write my original equation here. So we've got y equals the absolute value of x plus 1 minus 3. I know that x is going to be negative 1, or my x-coordinate for my vertex will be negative 1, so I'm going to plug that in for x right here. So when I do that, I get y equals the absolute value of negative 1 plus 1 minus 3. Okay, negative 1 plus 1 is going to be 0. So I've got the absolute value of 0 minus 3. Okay, well I know the absolute value of 0. The distance 0 is away from 0 on the number line is 0. So I've got y equals 0 minus 3. So y is going to be negative 3. So I've got my x-coordinate for my vertex, I've got my y. So the vertex is at the point negative 1, negative 3, where of course negative 1 is the x and negative 3 is the y. Okay, pause if you need more time. Okay, so now that we have our vertex, we must create a table of values. Okay, so let's start by picking x coordinates, also known as inputs. And I would recommend picking two x coordinates that are integer values. Okay, so a whole number that is positive or negative. Immediately to the left and right of the vertex. Plug these inputs in to see what their corresponding outputs, also known as y-coordinates, will be. Okay, so I'll make my table. I've got x, I've got y. Okay, I'm going to take my vertex and plug it right in the middle. So I've got -1, -3. Okay, so up here I said I'm going to take integer values that are immediately to the left and immediately to the right for x coordinates. So immediately to the left I've got -2, -3, and immediately to the right I have 0 and 1. Okay, so I've picked all my x values, or my x coordinates. Now I need to figure out what their corresponding y coordinates will be. Okay, so just as a reminder, my original given equation is y equals the absolute value of x plus 1 minus 3. So I'm going to take all these x coordinates, plug them in for x up here, okay, and that'll give me my y coordinate, or my output. So I'll start with -3. So when I plug in -3, I get, actually let me put, when I plug in -3, I get the absolute value of -3 plus 1 minus 3. -3 plus 1 is going to be -2 minus 3. The absolute value of -2 is 2, because -2 is 2 units away from 0 on the number line. I'm subtracting 3. So 2 minus 3 is going to be -1. So I'll take that -1 and plug it into my chart here. Now I'll do -2. When I do that, I have the absolute value of -2 plus 1 minus 3. -2 plus 1 is going to be -1. And the absolute value of -1, I know, is 1 minus 3, which is -2. Okay, so I'll plug in -2. So you can go on your paper and just keep writing down the inputs and outputs for 0 and 1, but just so I don't have to erase this chart here, I am going to erase all of this right here. Okay, so you scroll further down, or look further down on your paper. I guess you're not scrolling. I'll finish it up right here. So when I plug in 0, okay, I end up getting the absolute value of 0 plus 1 minus 3. 0 plus 1 is going to be 1. So I've got the absolute value of 1 minus 3. Absolute value of 1 is 1, because it's 1 unit away from 0 on the number line. And 1 minus 3 is going to be -2. Last one, I'll plug in 1. 1 is my input, or my x coordinate. So when I plug in 1, I get 1 plus 1 minus 3. 1 plus 1 is 2, so I have the absolute value of 2 minus 3. The absolute value of 2 is 2, so I have 2 minus 3, which is negative 1. Okay? So I'm going to scroll further down. So now we can just graph those points that we found. Okay? So for our chart, we had x, y. Oh, whoops. Okay, we had negative 1, negative 3, negative 2, negative 3, 0, 1, negative 2, negative 1, negative 2, negative 1. Okay, so now I'm just going to graph these points. Okay, so I'll graph the point negative 3, negative 1. Okay, so I go negative 3, negative 1, negative 2, negative 2, so negative 2, negative 2, and then negative 1, negative 3. Okay. 0, negative 2, so I'm at 0, I go down 2, and 1, negative 1, so I'll go over 1 and down 1. Okay. Notice how they form this V right here. When we're dealing with linear absolute value equations, they will always form this V. Okay, it could be an upside down V, but it will always form a V. Okay, so I will connect these points right here. And then I will connect this side over here. And last step, I'll add some arrows because these go on forever. So this is our graphed absolute value equation. Another way we could do this to save some work once you get going, if you find the vertex first, like we did in this method, okay, this equation or this function through the vertex has something called an axis of symmetry. And an axis of symmetry is an imaginary line that splits the function in half. Okay, so notice we have all these points over here, we've got this line that has a slope, and we've got all these points over here. So the left side is just mirrored by the right side. Okay, so for example, let's go to negative 2, negative 2, so we go over to the left 2, and then we go down 2. Okay, if we mirror that point, negative 2, negative 2, over onto the other side, we get 0, negative 2. Okay, same thing for negative 3, negative 1. If we mirror that over, we're 2 units away on the number line over here. Okay, we can mirror it 2 units away on the number line on the other side as well. Okay, so really all you have to do if you are finding the vertex and you are finding or picking x coordinates that have equal distance away from that vertex, you can just take these points and just mirror them right over. Okay, that only works though if you find the vertex first. Okay, at this point I would move on to the example video for graphing absolute value equations.